Okay, so apologies for getting this way later than I wanted to. Dealing with illnesses in the family last week, and I just kind of everything got pushed back. So I'm still going to make this week's homework assignment due next Wednesday. However, if you need to turn it in late, as always, let me know, and that'll be completely fine. But I just think it's probably best. I don't know. You guys might disagree, but I think it's best for everybody's mental health involved if we just try to get it done on Wednesday, so then you can go on to the next thing. But as always in this class, very flexible with due dates and stuff like that. Okay, so what I want to do today, in this lecture is I want to eventually, so the goal there's sort of like two goals. There's a video goal that I want to make. I want us to be able to make a certain type of video, but in making that certain type of video, we're going to learn even more stuff about Manim. So the main thing that I want to do is show you about Manim, but I'm going to do that by making a certain type of video. So one thing that you guys are probably aware of is that a circle, I can think about a circle as being a regular polygon. That is a polygon with a certain number of equally linked sides. I don't know why I'm having such a hard time to describe a regular polygon, but I can think about a circle as a limit of those. Okay, and what I want to do, and so then the area of the circle is going to be the limit of those areas. Okay, now mathematically, this has nothing to do with Manim. Mathematically, this is something that I think you guys should think about. One, because I think it's interesting, but two, if you teach this stuff, I think you need to be prepared for this question and have this understanding. One, why is it that basically any shape that approximates if you have two shapes, one easy shape like a regular polygon and a more complicated shape like a circle, let's say, or if you approximate the area under a curve with rectangles, why is it that the area approximation is good, but the perimeter approximation is bad? So as a concrete example, think about finding the integral of y equals x squared going from 0 to 1. If you approximate that region with rectangles, you get a very good area approximation that goes, like the error goes to 0 as the width of the rectangles goes to 0. But you get a very bad, whoops, sorry, my phone's dying. But you get a very bad approximation to the perimeter. So think about why that is. Anyways, that has nothing to do with Manim. Okay, so what I want to do in Manim is I want to do something. I want to make, it's going to be a very simple video. We're going to show a triangle, then we're going to show a square, and then 5-gon, 6-gon, 7-gon. I know those have names, but I'm not saying them. 8-gon, 9-gon, up to a certain number in gon, and we're going to show that it becomes closer. It's going to look closer and closer to a circle, and then we're going to display in the Manim screen what the area of each one of those polygons is. Okay, so that's sort of what we're going to do. Okay, I hope how I'm describing it makes sense. I'm going to give you like the beginnings of how to do this, but then the assignment that you'll turn in on Wednesday is basically just going to be finishing the project, or finishing the program up. Okay, so the first thing I want to do is I want to talk about polygons. How can I draw polygons in Manim? Okay, well I just Googled Manim polygon, and this is what I came to. Okay, class polygon, here's what it takes in. It takes in the vertices. Okay, so the vertices are going to be the vertices of the polygon. That kind of makes sense. And then any keywords. So let's see what those are. So the other thing that I'm trying to do here is show you how to use the Manim documentation so that you can figure out how to do this on your own. And there's also examples down here. Okay, so vertices is going to be a sequence of floats, the vertices of the polygon. Okay, that makes sense. And then the keyword arguments forwarded to the parent constructor. Okay, so what does that mean? The base class is the polygram. So I'm going to look at the polygram. Okay, and this is going to tell me all of the the keyword arguments are going to go here or in the Vim object, and so on and so forth. Okay, so anyways, I'm going to go back here. We're going to forget about the keywords for now. Just going to get the vertices of the polygon. Okay, and then here's an example, and here's all of the different things, all of the different methods that a polygon can do. Animate, animation overrides, all of these things here. Fill color makes sense. The height, I think this is only makes sense for three-dimensional graphics, which we're not doing, so on and so forth. Okay, so I'm just going to do an example. Here is my Manim thing over here. Okay, I just made this before I started, so if I run it again, we just get this. Okay. All right, so let's look to see what we have here. Position list. These are all of the different positions. So let's just think about making something very simple. Let's just think about making a triangle. Okay, so I'm going to say, whoops, T will be my triangle. So T, and this is going to be equal to polygon. And I'm going to give a list of vertices. So let's say I'm going to have one vertice at 0, 0. Sorry, I forget the format that they need to be in. Okay, so it's a list of list, an array of arrays. Okay, so 0, 0. So I need to put. So it's a this is a two-dimensional array. So 0, 0, 1, 1, and let's say -1, 0, and let's see what happens when we do this. Need to close that. Self.add t, and then I'll wait for a second. I'll wait for 2 seconds so we can look at it. I'm going to run this. Maybe there's a mistake. Yep. Okay, so sorry about that. The problem, I misread. So if I go back to the documentation here, if I go back to this documentation here and I look at this example right here, notice it's not an array of arrays, but if I want to use a position list like this, then I have to use, I'll talk about this in just a second. So let me talk about that in just a second. But if I just want to do something like this, it's not an array of arrays, it's just three different points there. Okay, so I'm going to come back. So I'm going to get rid of that, and I don't think this is going to work because I think there's one other problem as well. Okay, so if I come down here, all the input array dimensions except for the concatenation axis must match exactly. Okay, but along the dimension 1, the array at index 0 has size 3, and the array at index 1 has size 2. Now, I'm not completely sure what array this is talking about. I think it's talking about I think this error message, like the error message is sort of initiating with this function call here, but this is the stack trace, and it comes back to like where it originated, which is going to be this here. And so what it's saying, I don't know, I didn't look at the inner workings, the inner code for the Manim package here, but basically it's saying it needs to have 3 dimensions. Okay, so we're just going to set the last dimension equal to 0. And if we do this, we're going to get, we should get the triangles. We get a triangle like this. Okay. Okay. All right, so now you're like, well, okay, that's a good triangle, but what if I want it to be a little bit bigger? Okay, so I'm going to tell you how you can make things bigger. There's a built-in scale function. So now I'm going to say t dot, so I'm going to say t, well, let me say this. So st for scale t is equal to t dot scale factor equals 0.5. And actually, this is a little bit different than the example that I had prepared, so bear with me here. Sorry. So now I'm going to do self.add st. So it's just going to add it, and then I'll wait for 2 seconds. Okay. All right, so there we go. And oh, so I made it get smaller. So I meant to do 2 there for some reason. I did 0.5 instead. Okay, so now it's going to get bigger. Okay, so there we go. And then the video will play on a loop, so now you can just see a triangle getting bigger and smaller. Okay, and so let's come up here. Let's see what happens if I add another point. So let's go -1, 1, 2, 0. So T for triangle is probably not the best name for this, but let's see what happens when I run this. Okay, so now we get this shape as well. So pretty cool looking shape there. Okay, so I guess what we can see, excuse me. So what we can see is happening here is that it is drawing a line in the order that we have here, going from this point to that point to that point to that point, back to that point. Okay, for a triangle, you're going to get a triangle. If we were trying to get some other shape, we would have to put these in a different order if we wanted Manim to connect the lines differently. Okay, so that's all that I want to say in this video. I'm going to say a little bit more in the next video about the position list. So I'm going to say a little bit more about that in the next video, and then show you. Okay, maybe you guys are thinking, well, how can I use this to draw a regular polygon? Because this seems like it's going to be a very big hassle if I have to go in and literally put every single individual point for a regular polygon. Like, how am I going to do this? Maybe I can figure out how to do it. It seems like I should be able to think about how to do it, but I really don't want to have to mess with this. So I will show you, at least, maybe not in the next video, but in the following video, an excellent class that will let us do that.